So for our project on advanced health informatics, we decided to look at the statistics of 10 diseases in New York from 2000 to 2016. We focused on the number of occurrences of each disease in each year, if there were any, and our poster shows the analytics of the diseases that we gathered with respect to time given, which was years.
Hi, I'm Matthew Smith, and I will be going over the background of improving health informatics. Our data was about 10 communicable diseases found in New York City from 2000 to 2016. With this given data set, we hope that we're able to show the people of New York City how the disease is being increased or decreased in these areas. Hopefully they can learn and find ways to prevent the diseases from continuing to spread and increasing, or hopefully continue the decreasing of the disease. Inside this data set, we have 10 diseases that we have the cases and the percentage of people that were infected from these diseases so that we can search through and show the trends that from the given data that we are given. From this, we are able to show certain graphs and trend lines, as I have stated before, so that we can continue developing this over more years and increase the amount and things like that.
My name is Damian Young, and I'll be going over the final algorithm for our code. Once the code is started, the disease data is loaded in. After that, empty columns and strings are removed, and each row is condensed into individual vectors to make indexing easier. Next is a menu statement with two options, one to go through the data and find the number of cases for a specific disease over time, and another looks at all diseases for a specific year. I'll go over the specific year option first. The user inputs a year, then the code verifies that the year is in the data. The code then combs through the data and finds cases for every disease during that year and adds them up. These sums are displayed as relative percentages on a pie chart and as fprintf statements. For the second option, the user chooses a disease from a menu, then the code adds up every case of that disease per year. This is then plotted as a scatter plot with a trend line showing predictions of the number of cases for the disease 2 years after the data ends. After either of those options is completed, the code ends.
I'll be going over the first test case that will run through our code and its results and outputs. For this test case, our code will ask the user which data they would like to access in the menu statement. Here the user will choose to access data corresponding to a year. Then our code will prompt the user to input a year to view the relative presence in percent between the years 2000 and 2016. These are the years our data is centered on. For this test case, the user would enter 2016. Our code would then find the overall total number of case counts reported on that year, as well as the total number of cases for each of the 10 diseases in our data. For the results, a 3D pie chart will show each of the diseases' presence in percent. A formatted output will also be shown in the command window that displays the disease names and percentages.
Welcome to NAE Grand Challenge Advancing Health Informatics test case number 2. So let's get started. We're going to run our code, and what comes up first is a menu statement that says which data would you like to access, and since this is test case number 2, we're going to pick disease. What comes next is another menu statement that says which disease would you like to view its case count over from 2000 to 2016. We're going to pick meningococcal disease invasive. And what appears is a scatter plot with the years as an X value from 2000 to 2018. We added 2 more years to our X-axis because we also have a trend line that predicts how the number of test cases changes as you continue on from the last year of the data set. And our y-axis is the total number of test cases reported. That is it for test case number 2 of the NAE Grand Challenge Advancing Health Informatics.
Hi, I'm Austin Kanye. Overall, the program that we created helps to raise awareness in areas infected with diseases. The program can also be updated each year, depending on if a new disease develops or if a new disease has been wiped out from the city. Although the program can be updated, there are also limitations to this program. This code is limited to the diseases and neighborhoods in a specific city. In this case, the program is limited to the diseases and neighborhoods in New York City.